Going to solve simple logarithmic equations. So last week we spent the week talking about how we solve exponential equations. This week we'll spend the week solving logarithmic equations. All right. So last week, if it was an exponential equation, and this is all equations are this way. If you need to solve an equation, you use the inverse relationships. Excuse me. So if it starts off as a logarithm, you're going to need to use exponents to solve it. So the ones that I'm going to show you today are going to be things like this. And we'll start off with a really easy one. If I go log of, let's just say, 3 of x equals 4. Okay? Now, when I give you a logarithmic equation is when the variable is in that part of the log. Okay? So if I gave you something like this, log 3 of 12 equals x, even though the log is here, this is not a logarithmic equation. Okay? That's where the x is. This is a logarithmic equation. Okay? So in order to do this, in order to get that x out of that set of parentheses, you need to use the exponential rule. And it was this. Remember saying if log base b of x equals y, then b to the y equals x. Remember that? Taking this as your base, raising it to the y, and it comes back and gives you that x, right? Every time we solve one of these logarithmic equations I give you today, that's going to be the route you go. So you're going to take your 3, which is your base, you're going to raise it to this exponent, and it's going to come back and give you x. Okay, now this is simple because you don't have to do anything now to solve for x. It's already solved for. Okay, 3 to the 4th is equal to x. Now, you can, and it probably makes sense, to go ahead and change. Does anybody know what 3 to the 4th is? 81. So it makes sense to change that to 81. Okay, but you could, if you wanted to, leave it as 3 to the 4th. I don't know what Math Excel would want. Probably the 81. If you plug that 81 in now, if I go log base 3 of 81, type that in my calculator, calculation will spit back 4. Does that make sense? So, how do we make this a little bit more difficult? We do things like this. We say, okay, well, let's go log base 4 of, let's go x plus 1 equals 2. So now instead of just an x in here, we've got a sum. But we still use this rule. Okay, take your base, raise it to the y, comes back and gives you x. So what's my base over here? 4. You're going to raise that to the second power and come back and give you x plus 1. Now, can you solve for x? I would change the 4 squared to 16 first. Then you can isolate x by subtracting 1. And you get your x to be 15. Okay. We can check that. Check all of these. If we go log base 4 of, we'll say a plus 1. Okay. and then make A go to 15, and you see that it comes back and gives me the 2 that we were looking for right there. Is that something we can do? Now, this thing here can be anything. Okay, so let's do let's go log base 5 let's go x squared minus 50 equals, let's make that plus 50 equals 25. Let's see what that one looks like. No, not 25. 2. I'm getting ahead of myself. Right that way. Log base 5 of x squared plus 50 is equal to 2. Okay. Same approach. You're going to take this number here, this 5, raise it to your second power. You get 5 squared is now equal to, it comes back and gives me that thing, right? So equals x squared plus 50. Okay. That gives me 25 equals x squared plus 50. Okay. Anybody remember how I go ahead and solve this? If it's x squared, okay, so some stuff to remember. If x squared, that means you want to factor. Okay. If there is no x to the first term, use square root method. So when I do this, I'm going to subtract 25. When I want to factor or solve for an x squared, and there's no x to the first, I can use the square root technique, which means isolate this. We're subtracting 50 from both sides. I get negative 25 is equal to x squared. Okay? I can do that and now take the square root here and the square root there. Now, this is something that we haven't talked about too much. Okay? But we have mentioned it. Can I take, remember what the square root symbol is. It's a symbol for a number that when I multiply it by itself 2 times, I get, in this case, negative 25. Can you take a number and multiply it by itself and get a negative? No. My option is there. If I take square root of negative 25, most people are going to say it's either 5 or negative 5, right? If I take 5 and multiply it by itself 2 times, I get 25, not negative 25. So I can't be 5. If I take negative 5 and multiply it by itself 2 times, I get negative 5 times negative 5, turns into positive 25. So there's nothing that I can multiply by itself to get negative 25. So this tells me that there's really no, we call them no real solutions. Okay? We talk about that because, and we'll get into this in the next couple of weeks, there are imaginary solutions. Okay? Which is, makes people think that they don't really exist based off their name, but they do. But let's look at the graph of this and kind of convince ourselves of why this is the case. If I look at log base 5 of x squared plus 50, which is that thing right there, okay, that weird looking curve. And if I say, does that equal 2, which is that line right there, the place that they are equal, the answer to the solution is where the green and the red cross paths. It's the x value of where they cross paths. Do they cross paths? I zoom all the way out here. Is the green going to intersect the red anywhere? No. And what actually happens is that the distance between the red and the green is actually going to increase forever as we move further to the right and to the left. So those two things never intersect, and because they never intersect, that might shed light on why we have no real solutions. Okay. Let's do another one like that, but we'll have some solutions here. Let's go log of 10, log base 10, give me a moment. I'm trying to think ahead here with making these a little bit simpler. Let's make this actually negative 3x here. So log base 10. Okay. Now they could also present that without that 10 there, right? And we'd have to assume or know that they're talking about a base 10. But again, we're going to go to solve this. We're going to take our 10. Jenna? Not doing the homework right now, are you? No. So say it again. Yes. Yep. So something like that. Okay. So the question was, if it looks like this, do we do a send? Yes. So the common log means we know that's an automatic 10 then, so you would still turn it into this. Okay, so now this is when you have an x squared with an x to the first term. Okay, you need to factor, and that means get things equal to 0. Okay, so I need one of these sides to become 0. So my suggestion to you, this one's going to be easier if I make the 10 turn to 0, right? So subtract 10. Come over here and subtract 10, and we get 0 equals x squared minus 3x minus 10. Okay. Now, if we have this setup, remember this is an ax squared plus bx plus c equals 0 setup. When you have that, there are several different techniques that we can use. First one you're going to try is the product sum technique. Are there two numbers that multiply to give you negative 10, but add to give you negative 3? So if we think about those numbers, multiply together, give me negative 10. So that means I got to have 1 and 10, maybe that one's negative, that one's positive, or 1 and negative 10. Did those add to give you negative 3? So those are not the option, right? So then I try 2. 2 and negative 5. Do those add to give me negative 3? So those are my choice. So this thing's going to turn into 0 equals x, and then that number there, It's a positive 2. And then x, that number there. So minus 5. Just remember doing this? Okay. And then we could say, if two numbers multiply together and give me 0, then x plus 2 equals 0. X minus 5 equals 0. So x is negative 2. And x is 5. Here we have two solutions to this problem. So when I graph this, graph as log of x squared minus 3x. It knows, when I just type in log, it knows to use the base 10. So that's this curve here. Okay. If we want to see where does it equal to, or no, sorry, it was 1, wasn't it? 1. So say y equals 1. Okay. Now we get the purple curve and the black line. We go see where they cross. They cross right there at an x value of 5, and right here an x value of negative 2. And that's exactly what we came up with by hand. Does that make sense? You guys remember, so depending on what this formula is right here, or this equation comes from, this expression will dictate the equation. If it's quadratic, you guys remember dealing with this thing. And you can program Desmos to do this for you real easily. If I go opposite of b plus the square root of b squared minus 4ac all over 2a, we can do that. We're going to copy that, paste it, and then change this to a minus sign. You guys remember the quadratic formula? Okay. Now, so this will allow us to factor this thing just like, and get these two answers right away. So what I can do is I can put A as this 1 right here, correct? So I say A equals 1. I want B. What's B going to be? Negative 3. And C is negative 10. If I type those in, go back up to the formulas, does it give me the two answers that we were looking for? Okay, 5 and negative 2. Okay, now, this is the quadratic formula here is your safety net, right? So what I would do if I were you is maybe you see where it says share graph here? You can copy this. And now I'm going to go to, so I'm going to close this all out, leave it, paste, and go. And now it's that I've made it once, copied the URL, and I can always come back to this now. Does that make sense? And now you don't have to type this in a second time. You just type in your A, B, and C, depending on the problem you get, and you've got then the answers calculated instantaneously for you. Okay? So I would suggest maybe building something like that to assist you when you get these more complex equations after you use the logarithm or the exponential rule to generate the equation. Okay? Yes, Noah? What if you missed something? Middle class? Are you serious? So if we've got something like log, like 3, let's just go x plus 1, like equals like 1/8, something like that. So I'm just going to take 3, raise it to the 1/8 equals x plus 1. Okay. Now, a lot of time I would assume that the problem they give you is probably going to be, I will do another example here in a moment, but it's probably going to be a nice value that you can evaluate that easier. But if you remember, anything raised to a fraction like this, we had the rule that if I had like x raised to the m over n, I could change that to the nth root of x to the m. So in my problem here, I'm going to go 3 underneath the radical. It's going to have the m was a 1, so it's going to have a 1 right there, and it'll be an 8 right there, equals x plus 1. And now it's asking me basically, what is the number that I multiply by itself 8 times to get 3, which is kind of ridiculous to ask that question. And that's not a common number off the top of our head, so we'd probably just leave this as the 8th root of 3 minus 1 is equal to x, like that. Okay? But what they probably do, I would assume, in your homework is something of the nature, like if they go log, let's say, 4 of 2x plus 3 equals a half. So there we're going to go 4 raised to the 1/2 equals 2x plus 3. Then this 4 to the 1/2, you're going to still use that thing right there. So I'll have the square root of 4 to the 1st equals 2x plus 3. But what's the square root of 4? 2. So they probably try to at least write that number there and that number there together well enough so that when you do take the square root or the cube root or the 4th root or whatever, it turns into a nice integer. Might not always be the case. So we get that. So what number? So what's the question that you're getting there? Do you have an example? X minus 1 equals 1/2. Okay. So then again, they're going to go 9 to the 1/2. Come back to give you 3x minus 1. 9 to the 1/2 is the same thing as the square root of 9 to the 1st. So that will turn into 3 then. It gives me 3 equals 3x minus 1. It's a good question. Does that make sense now? All right. I'll give you guys the remaining time to start and hopefully finish the assignment. I think I called it 7.6 in Math Excel.